be quiet. So if this object is, let's say, these forces make the object make the object's acceleration point toward the center. So if the object's acceleration is pointing toward the center for a long period of time, then the object will eventually fall. But if the velocity is high enough, such that if the velocity is high enough, then the object won't point in the direction of the acceleration. It would take longer for the object to point in the direction of the acceleration, and then the object is not going to stay at this position for a long period of time anyways. So that it won't be since it won't be at this position for a long period of time, it would eventually go around in a complete circle. So and we know that for rotational motion, that sigma fc equals mv squared over r. So if this is greater than or less than the normal force plus the gravitational force at this instance of time, then the object will go around in a complete circle. And then to get a more clear gist of this, you could say, to get a clear more gist of this, of why when an object has a really high velocity, it won't point in the, like, if the object's velocity is not high enough, the object wouldn't take a long time for it to go in the direction of the acceleration. Like, for example, we know the equation. We're all familiar with the equation. We're all familiar with the equation V B F equals V I plus AT. So let's say the initial velocity is positive 1 meters per second. Let's say in the positive x direction, whatever you choose that to be. And let's say that the magnitude of the acceleration is anti-parallel to it, and it's, let's say, 5 meters per second. And let's say the final velocity of the object is 0. No. And let's say, forget about the final velocity. Let's say the final velocity of the object is not 0. And then let's say for 2 seconds. So for 2 seconds, the object's final velocity would be negative 9 meters per second. So for less than 2 seconds, the object's velocity is already pointing in the direction of the acceleration. I hope that's not too confusing for you.